Welcome to Ask and Learn.
And for ball 1 should take this form. Right? And both balls have the same beginning and ending spot, right? So I'm not going to differentiate between them. I'm just going to leave it as YF and Y naught. Okay, but they do have different speeds and different times. Okay, so then first off, I'm just going to solve for T1 here. All right, so we have 300 equals 0 plus 160 T1 minus half 32 T1 squared. And then we can rewrite this as half 32 T1 squared minus 160 T1 plus 300 equals 0, right? And you can put this into Wolfram alpha, and then you'll get T1 equals 2.5, and let's see, the other one, 7.5. Okay, now it can't be this one because the second ball takes 3 seconds to go up, so it wouldn't have time to meet up at this time. Okay, but also since the second ball is 3 seconds behind the first one, its time is T1 minus 3, okay? And also that means that its time is 7.5 minus 3, or 4.5, okay? But also, its kinematic equation should look like this. Alright, and this is 0. So then we have 300 equals V naught Y 2, 4.5 minus half 32, 4.5 squared. Okay, so now we just got to solve for V naught Y 2. Okay, so then we have half 32, 4.5 squared plus 300 equals V naught Y 2 times 4.5. Okay, so then V naught Y 2 is equal to half 32 times 4.5 squared plus 300 over 4.5. Okay, and that is about 138.67 feet per second. Okay, but also, in regard to that second question, it's descending. Okay, ball 1 is descending. Descending, I'm going to go right back to that kinematic equation for ball 1. See, because ball 1 has 2 different times associated, right? So when ball 1 gets shot up, it passes that height twice. The first time is 2.5, the second time is 7.5. Okay? We said 2.5 isn't an option, so then it must have overlapped with the second ball while it was descending. Okay?